many Texas bridges use simple span girder decks. But because of expansion joints in these type of bridges, issues with durability and maintenance can arise. An approach to intentionally form cracks called a Texas Poor Boy method has been used for decades, but there is no comprehensive assessment of this technique. Researchers with the Texas A&M Transportation Institute and the Texas Department of Transportation surveyed the performance of the current bridge methods to make recommendations on new construction and rehab designs.
When you're building a bridge, you've got multiple spans, and between those spans, there's a gap between the ends of the girders. This is intentional, and it allows for thermal expansion.
With the weather in Texas being hot and cold, the bridge is actually going to move quite a bit and want to expand and contract. So that's what the joint is there for.
These often involve lots of maintenance and can allow water through that can eventually damage the substructure beneath the bridge deck.
Ultimately, what we would like to do is we'd like to be able to remove that joint from a bridge system and just make those spans continuous all the way through, which would be no joint from start of the bridge to the end of the bridge.
Have the deck be continuous over the gap, and hence the name continuous deck detail. Because the girder deformation introduces stresses into the continuous deck, there are unique design considerations for this portion of the bridge deck relative to the rest of the deck.
We're able to build a computer model that showed the initiation of the cracks. Then we were able to take that into the laboratory and replicate that exact data into the full-scale models.
We had students build 4 bridges with 6 unique designs on them. 2 designs replicated existing details, 2 designs implemented retrofits, and 2 designs were proposed new designs. The new designs were selected for testing based on the results of dozens of options investigated in the computer models. The benefits of full-scale tests is replicating the exact details in Texas bridges. Such details have been absent from prior research on link slabs, yet these details are critical to where cracks develop and how severe they are. The test successfully replicated damage in existing bridges, with the new designs shown to improve the performance greatly. One aspect of the new designs is to allow for more flexibility of the deck. Another aspect of the new designs is eliminating some details that allowed cracks to initiate.
So the benefits for the department will be we get to eliminate that expansion joint, or the need for that expansion joint, which would then further reduce our maintenance cost and a few headaches in the future. For the traveling public, this would also mean that we could probably have a smoother riding bridge. When you obviously have to put in that expansion joint, you have to start your concrete placement and then finish at the joint and then start back up at the other side of the joint. So that kind of gives it the bump in the middle of the bridge usually. So we would be able to get away from that and actually have a continuously graded slab, so it would be a little bit smoother.
For more information and to find the publication for this project, please visit the TxDOT Research Library at the link shown below.